In the last nugget, we looked at HSRP in all its glory, which is great, because now we have the foundation for both VRRP and GLBP. Well, this should look familiar. It's the same world we were looking at with HSRP, however, now we've transformed it for VRRP, and things get a little easier. If you are a really observant person, you may have noticed that my steps went from 4 down to 3. Here's why. You remember from the last nugget, we've got this set up as the 10.1.1.0 network. This router on the left has .1 and this one has .2. Now I've reverted back to the original configurations. This one up here is the 10.1.2.0 network. And we actually have a server here rather than the cloud where we're communicating with. Again, same story, .1, .2, because we've reverted back to our previous config. Now, you might remember from HSRP, we went in and created the HSRP group. Immediately got an error message because we said, I want the virtual IP address to be .1. That these two share. HSRP was like, sorry, that's already assigned to this interface. You need to change that. So that's where we said, okay, well, let's make this .3. Is this remembering, being a little familiar? That was our previous step too, was to change that IP address to a different one. But now with VRRP, we don't have to. With VRRP, here's the rule: whoever has the virtual IP address assigned as their own IP address, meaning that's the IP address they're using on the interface, they automatically become the master, meaning they are the active router forwarding traffic. It's kind of like take the priority, put it aside, because priority doesn't matter anymore. You have that virtual IP address. You supersede everything. So whoever has that automatically becomes the master router. The others move into that standby or that backup status that they're going to use going through it. So otherwise, everything is going to feel really similar. Let's bring this up. I'm going to open up router 1. And I literally went through and rebooted every device, no save config. So we've got, let me do a show standby from the last nugget. There's nothing there. There's no standby configuration. So I'm going to go on router 1. Again, orientation, show IP interface brief. We see the .1 IP address on each one. Into fast Ethernet 0/0. And we will do and remember before we were doing standby and the group number and all that kind of stuff. Okay, this is just going to be VRRP and the group number. So we'll say group number 1 that we're going to use between them. Now, tell me this doesn't look familiar. It's kind of like, wait a sec. Are we still doing HSRP or is this VRRP? It's the same exact commands: authentication, description, what IP address. Do you want preemption? Do you want priority? To set a certain priority. So let's go through them. Let's do VRRP1 IP address will be 10.1.1.1. Notice no error this time. Rather, it says, okay, you are now the master. You've adopted this as your virtual, even though it's your IP address as well. This is also your virtual IP address. Now, VRRP also has, all the same options as before. We've got authentication. We've got the priority that we can set. Now, one small difference is in the preemption. Preemption on HSRP, you might remember, was not the default. But let's just drop back here. Let's do a quick show VRRP. And we can see that by default with VRRP, we haven't typed anything in yet. And preemption is the default. So when Cisco put VRRP in, it's an RFC standard, the standard said this is going to be the default. And if you want to disable it, you can. Now, I would say that's probably, well, I still, I would say, 6 half dozen, 12 the other, right? It's kind of like who wants preemption, who doesn't. It's really a gut feeling. I'd say more people lean towards the direction of preemption because they have one kind of bigger router, or who knows. But nonetheless, it is preemption enabled by default now. So what else do we got? We got to jump over to router 2, right? So let's get our console connection up there and just get a little VRRP love happening between these two. Let's go into interface fast Ethernet 0/0. We'll do VRRP group number 1. IP 10.1.1.1. So he's saying, I'm also responding for 10.1.1.1. He automatically goes into a backup status. Now, just a terminology game, when Cisco wrote their priority standard for HSRP, they said, we're going to have a active and standby router. When the standard was written for VRRP, they said, we want to be different. We're going to call it a master backup relationship. So same kind of thing, but sometimes how exams are. I see something in the master status. What protocol am I running? It like you're really going to care about that. But anyway, just something worth mentioning. So we now have this one become the master. Now you can see that the priority on router 1 is automatically set to 255. Now, let's do a show VRRP on router 2, and the priority is 100. Now you notice we did not type in any priority commands on router 1. We just left it at the default. It is because he has the virtual IP address assigned as his actual IP address that it automatically gives him the priority of 255. That's why he becomes the master router every single time. If we were to change his IP address, his priority would drop to 100, and now we're back to the highest IP address wins, or you can go in and set the priority using the VRRP group 1 priority command, right? Okay. Well, I don't just want to kind of go through all the same stuff as HSRP because the concepts are truly the same. I think the only thing that I want to show you that's really different is first off that we know the timers are by default lower. We saw that from the concept. By default, VRRP says hello every second. It considers somebody down if they don't respond in 3 seconds. So we know that, and we can adjust the timers into the millisecond status in the same way. But I think the big thing, well, the only real thing I want to show you is tracking. So rather than interface tracking, remember we said, with HSRP, we can track an interface. If it goes down, the priority can drop a certain value and all of that. VRRP supports the same thing, but instead of just allowing us to go simple and type in the object of serial 00 or fast Ethernet 01 or whatever the case may be, it goes in there and says, okay, well, I am going to require you to use a track object. So let's talk about that. Track objects do exactly what they sound like. They track things. Now, what they track can be a whole gamut of items. I would say that the one that's most relevant that you mostly see being used is the line protocol. You remember when I first introduced the show IP interface brief command. One of the things we saw, let me just, I'll just hit enter. Do show IP interface brief. One of the things we saw is this. We have the protocol or line protocol of that status. So a track object can say, okay, I'm going to track the line protocol. If it's up, then the track object says, okay, we're good. If it goes down, then the track object says we're not so good. But it can also track some other things. For instance, it can track specific routes in the routing table. So I can say, you know what, if we have the route, 192.168.10 in the table, then we're good. Then life is good. It seems like this router is doing okay. If that route goes missing, then we're not so good. That means we lost connectivity to maybe a key relationship or a key peer. One of the ones that I think is most exciting is you can use track objects for something called SLA probes. So what SLA probes do is send a probe. I was going to say a specific kind of message, but really probe is the best name you can say for it. So here's the scenario. Let's say we've got a couple routers right here, and let's do this. This one is a cable modem, right? This one is a old school T1 line. Now, the cable modem gets a lot more bandwidth. It's you get a ton of bandwidth for very little money on a cable modem connection. However, it is not as reliable as the T1 line. The problem with the cable modem is if you have a router, and let's say you've got the cable modem plugged into the router right here on fast Ethernet 0/0, and then it goes out to the internet. If the connection between the cable modem and the internet goes down, you never know about it because the cable modem is still reporting that your line protocol is up. Like the interface never goes down. It always shows up to the router. So if you're using, for instance, interface tracking and you're saying, okay, watch that interface, the interface is always going to show up. So even if the cable modem connection to the internet goes down, the interface shows up, so it will never show a down status, and this guy continues to forward traffic. It never fails over to the T1 line. Well, with SLA probes, what I can do, and let me just give you a basic method, is I can go in here and I can say I actually want to ping maybe a really reliable server. Like let's take Google's DNS server, 8.8.8.8. I want to ping 8.8.8.8 once every 30 seconds from my router. And if those pings start failing, that may be indicative that this section of the line is going down, or maybe some failure further on in my service router has occurred. And I'm going to declare essentially that track object as invalid. So here's the big picture concept. What we can do with VRRP as well as HSRP, it's just now we're forced to do it with VRRP, is define a track object that's associated here. So I can say, so let's first off create the track object. We'll go into, you create them from global configuration mode. So I'll say, I want to track, and you create an object number. Let's just say object number 1. I want to track the interface fast Ethernet 0/1, right? And it says, well, what do you want to track about it? Certain IP parameters, like is there a certain route or address associated with that? Or do you want to track the line protocol? That's the most common one that says, okay, if that interface goes down, I want to know about it. Now we come into the track object and we can say, well, maybe if we have an interface that goes down only for a certain amount of time, we can not invalidate this track object. I mean, it's got other options, but you don't have to configure any of those. You can see there's not many. So now when I go into fast Ethernet 0/0, let's go back to VRRP. So I'm going to say I'm configuring VRRP1, and I'm going to do a track, whereas with HSRP, it made it really easy. I was just like, track that interface. Now I'm going to say I'm going to attach track object 1, the one that I created right here, right, which says track that line protocol. So I'm going to say track the object 1, and I'm going to decrement the value of 60 if we fail. Now you saw the error message that popped up when it came up there. It says tracking is not supported on the IP address owner. This is one of the drawbacks of using the IP address as your own, is it can't lower its priority. So if I go in there and I say, okay, I'm assigning this IP address to this router, there is no, you don't have the ability to do object tracking, because it says, okay, my priority is hard-coded. I am always the master because I have this IP address assigned as my logical IP address. So, initially you're like, wow, that's a big advantage. But when you start saying, well, but you can't use features like object tracking, it's like, oh, okay, maybe I want to pull back on that. That may be a good plan. So we can shoot over to router 2, demonstrate the same thing. I can go and create track object, let's just say track object 10. The number doesn't matter, it's just, pick a number. We'll say the interface, fast Ethernet 0/1, and I'm going to track the line protocol. Okay, to where that's now created as a track object. I'll then go into fast Ethernet 0/0 and do VRRP group 1, track, and we'll say object number 10, decrement. Let's just say 50 if we lose that track object. Now you can see it takes the command. For sake of time, I'm not going to get into how to track all of these different things, but I will say if you are interested in track objects, it's just a Google away. I would Google it and you'll be able to see how to create, for instance, SLA probes, because you can have it do things beyond just ping. I can say retrieve a web page over that link. Seriously, you can tell the router, go out and retrieve a web page, and if you can't get to that web page or you get no results back, then go ahead and consider the track object down. I mean, there's a lot of flexibility when you start increasing or start encompassing all of what the track objects have available to them. Well, let's dive into our final protocol, GLBP, Gateway Load Balancing Protocol. And actually, now that I think of it out, I don't know if I've expounded all the acronyms. So HSRP, Hot Standby Routing Protocol, right? VRRP, Virtual Router Redundancy Protocol, and then GLBP, Gateway Load Balancing Protocol. This one, a mirror of HSRP, other than the fact that it is the only protocol that allows load balancing, meaning multiple active routers at the same time. Pretty powerful. So when we're looking at this configuration, and what I've done is rebooted all of the routers, so they've got a clean config. It's going to be mirrored to HSRP. In that, number one, we've got, let's say, the network 10.1.1.0 down here. We cannot assign the primary IP address to any one router, even more so in this world, because because when we're load balancing, I mean, essentially, there's going to be multiple people active on that IP address at the same time. Now remember how this works is GLBP creates multiple virtual MAC address. So based on the ARP requests that are coming in, it will start doling out different MAC addresses for that ARP request, thus sending people to different routers along the way. We'll actually see that when they do the configuration. So first things first, I've rebooted these routers, so we got to make a quick IP change. Let's go to router 1, do a quick show IP interface brief. And let's go fast Ethernet 00 IP address 10.1.1.1.3. Okay. And if we wanted to do it on the other side as well, we would hit the up arrow and just kind of blast that guy as 2.3 if we're doing redundancy on both sides. So let's get back to fast Ethernet 0/0. So with this one, we're just going to use the command GLBP. I think HSRP is the only weird one to remember. Remember, HSRP, we configure it using the command standby. Whereas the other two, actually you just type in VRRP and a group number, or GLBP and a group number. So that's where we're at right here. So I'll do GLBP question mark. You can see the group number. I can do 0 through 1020. Let's just use 1. I don't like using 0. Just creeps me out. So I'll hit the question mark, and it's kind of like, hello, same thing another day, right? So we'll do GLBP1. Let's get the IP address, virtual IP address 10.1.1.1.1. And meanwhile, let's shoot over to router 2. GLBP. It's already got the .2 address, so I don't have to fix that. 1, IP address 10.1.1.1. Okay, good. So now we've got 2 of them configured for that group. And honestly, if you wanted the basic configuration, you can be done right there. GLBP is going to build the group. It takes a little longer, I've noticed, for GLBP than the other two to become active. But it's going to build that group membership. And there we go. We've got router 1 down at the bottom that has moved into the active role. And start load balancing. It's going to start going back and forth. Let me show you. I'm going to go down here to router 1, and let's do a show GLBP. Good. I was waiting for router 2 to go active. And we can see that right up here it says state is active, a couple state changes. Hello timer. Now, it grabs the same hello timers as HSRP. So in aggressive environments where you need to aggressively fail over, you may want to lower those. But you can see active is local, standby is unknown right now. Now, this is what I wanted to show you. Actually, all of this right here. First off, notice the default load balancing method is round robin. That means that when we have our clients, the first ARP request will get the MAC address of router 1. The second ARP request, obviously different clients, will get the MAC address of router 2. And then back to the first, it kind of just keeps going back and forth, or through however many members you have. And you can see it has already told us what the virtual MAC addresses are. Check it out. This guy is the virtual MAC for router 1. This one is the virtual MAC for router 2. Now, keep in mind, in GLBP, we have the 2 roles, right? AVG, active virtual gateway, of which you're going to have an active router. This guy's going to be the one actively doling out those MAC addresses. So he is the ARP responder. I'll just put respond right there. He responds to all the ARP. All the rest of the routers, including the first one, are considered AVF, active virtual forwarders. So this guy is both an AVG. He's the one who doles out the MAC addresses, and he is the AVF as well, right? Everybody good with that? So when we're talking about the priority, you can see we still have that priority deal. That only, since everybody's forwarding at the same time, we're not saying who's forwarding and who's not. What we're using the priority for is who becomes the active virtual gateway. Who's the one that responds to all the ARP requests coming from this? Now, it's not. You might say, well, I want the bigger router. Well, most of the time when you're doing this, you've got cloned routers anyway. You bought like a pair or 3 of all the same routers. But it's not that big a deal for a router to respond to ARP requests. So I wouldn't stress over, oh, that's going to be a lot of load. Not really. So honestly, right there, we are good. We are ready to rock. We can do, we're verifying it. Everything is active. It's actually doing load balancing right now, trying to do equal by doing the ARP. So let's talk about tweaking it then, right? GLBP question mark. We'll do group number 1. We've got I'm not going to do the duplicate ones, but authentication. We've got load balancing. Okay, so here's a new method. Here's a new kind configuration. So load balancing, we have the option of doing host-dependent round robin or weighted. Now we've already talked about round robin. Essentially, every ARP request gets kind of the next MAC address. Okay, next, and down the line. Weighted. Well, let me hit host-dependent first. Host-dependent it uses kind of a hash for the MAC addresses, so the same host always goes to the same gateway. It's still going to kind of go back and forth, but it's going to use a hash algorithm. So you know if you're on a host, that one host will always go out one gateway. The reason that one's nice is because it's good for troubleshooting. I mean, the other ones, who knows which gateway you're going to get, right? It's kind of like a box of chocolates on Forrest Gump. So round robin and weighted, you might have clients that are going to different gateways at any given time of day. However, if you use host dependent, and all of a sudden, let's just say half of the hosts on your network start failing, and it's the same half that keeps having issues. I mean, then you can kind of be like, okay, I'm seeing, these guys must all be going to one router, and it's the same ones every time. So it's helpful for troubleshooting. Weighted allows you to define percentages, proportions. So I can say, okay, active virtual gateway, I want you to hand out 60% of your MAC address and 40% of the other guy's MAC address in an attempt to try and load balancing. Now, is that going to be perfect? No. I mean, because he may hand out the 40%, he may hand out router 2's MAC address to a evil client who's downloading things using peer-to-peer file sharing, and he's just gobbling up bandwidth. So it's kind of a roll of the dice, but we're just trying to play the proportion game. If I've got 60% of the ARP requests, 60% of the users going to one versus the other, it's generally going to load balance a little better to where router 1's getting the bulk of the load. So you can weight those however you want, right? So that's the load balancing options that we can configure. Okay, I had to actually pause and sit for a moment because I thought, well, that's it. That's all the other options are virtually the same as it was with HSRP and VRRP. There is one more that's slightly different, and that's the weighting. I would probably say this is one of the more confusing ones. If you're not thinking, well, let me explain it. So weighting is how eligible is a router to become an active virtual forwarder. See, this is a little different. Remember how we had interface tracking with HSRP and VRRP? Well, when we had that, essentially it would lower the priority such that the router would just shut down and wouldn't become. It would say, okay, I'm demoting myself to a backup or a standby. Somebody else can become the active because maybe I lost one of my interfaces. Well, with GLBP, everybody's forwarding at the same time. So we have to have a system that allows one of these guys to demote itself out from forwarding traffic and allow somebody else to take over for his virtual MAC address. So the way we do that is through a system of weighting. Let me show you the command, and then it'll make sense. So we do GLBP. We'll do group number, and you can see right here is weighting. So I'm going to set the weights, and then we'll do the interface tracking. So we've got weighting maximum value. So think of this. I don't like that description at all. It should say weighting, like start value or something like that. So let's just say I'm going to start from a value of 100, right? Now it says, okay, well, what is your lower and upper threshold? So let me define this, and I'll explain it. I'll say the lower threshold is, let's just say 75. And the upper threshold is 95, right? So I'll hit the enter key. Okay, so think of this like a big old beaker. So at the very top of the beaker is the value 100, and then we have these mystical lines in here. We'll have the upper threshold at 95. I'll just put a U right there. And then the lower threshold, L, at 75. So the command itself doesn't really do anything until I combine it with object tracking. So this goes back to, remember we just saw VRRP and the track objects and all that. GLBP does the same thing. So what they allow you to do is, let's say this guy's got a whole bunch of connections. He's got, ISP1, ISP2, and ISP3 that he's connected to. We'll just say serial 0, serial 1, serial 2, right? So what you can do is you can say, okay, I'm going to set up object tracking that says if he loses serial 0, then go ahead and subtract, let's go with 15 from his priority. Okay, what that will do, so let's just say I track serial 0, serial 1, and I track serial 2. Each one of them I assign 15 priority points to, or 15 weight points. I don't know what to call them. 15 points in the system. So what happens is, let's say all of a sudden life is good, and then serial 0 goes down. What happens is the router will say, I am going to take off 15 priority points, which will take me down to 85. Right? It puts them right in between this upper and lower threshold, and everything continues as normal. Since you haven't gone beyond the lower threshold, the router will not remove itself as a forwarding entity. All of a sudden, disaster strikes, 2 WAN links at the same time. Had to be a backhoe involved there. And now we've dropped down to 70. Okay? So now we're back down to 70. At this point, we say, okay, we just went below the lower threshold. This guy is now demoted. He is no longer an active virtual forward. He's removing himself from the pool. Router 1 will take over for both virtual MAC address. I'll put virtual MAC 1, virtual MAC 2 that he's now responding for. Okay. Now let's say serial 1 comes back online. It's like, oh man, sorry about that. Plugs it back in. This now puts him back up to 85, but he's not good enough yet. Okay, it's going to say, I'm not adding you back into the forwarding pool until you get past that upper threshold. Essentially, the rule is saying, okay, you lost one interface. We'll see how it goes. Okay, you lost 2 interfaces. Okay, something is definitely wrong. And all of a sudden, one comes back up. It's like, okay, I'm not comfortable adding you back, router 2, until such time as I see all your interfaces come back online. Does that make sense? Save that. because when you go and configure it, every time I do it, I look at it, I'm like, now what? Now what? It just takes a bit for it all to come back in. So that's how it all goes together. So now remember, track objects can be more than just interfaces. So the second piece of this configuration would be to go into the GLBP. GLBP1, and we would do the weighting, but this time we would define our track objects, and that's, again, same thing as VRRP. So I guess here we have a little dissimilarity from HSRP. This one does not allow you to just type in interfaces and penalties, if you will, like HSRP does. We still have to go back to global config mode, just like we did with VRRP, define whatever track objects we want, and then what penalty, let's just say 50, what penalty will be assigned for that track object going down. We'll say that's where our 15 would come in if track object 50 may be monitored serial 0, the serial 0 interface. And that is pretty much it. I mean, you can see right here I have step 4, additional tuning, but that's just all the other options that we talked about previously, so I don't want to have to run through them all over again, but that's where we can go in and do the authentication, the preemption, the timers, the load balancing of the IPA. So all of the different options that we had previously can also be configured with GLBP. That brings our FHRP, first hop redundancy protocols, to a close. We've now seen 3 different router redundancy protocols. HSRP, the original Cisco proprietary. The industry caught up, created VRRP, and then finally Cisco responded with GLBP, the only one that can load balance. Put those all together and you have a pretty powerful solution for redundancy and even load balancing on your internet connections. I hope this has been informative for you, and I'd like to thank you for viewing.